Yeah. So good day again, everyone. Let us continue our discussion on or on sensors. Okay. So the last video, we were able to tackle temperature sensors, no, its types and how it works. So basically, the following videos will the following slides and videos we will talk about other types of sensors. Okay. So let us continue. No, we have here another type of sensor, which is the light sensor. I also prepared 1 minute video for this slide. Anyway, let us continue. I have here four types of light sensors. We have the photodiodes, the photoresistors, phototransistors, and the CMOS. No? So basically, these light sensors all convert lights into various other energy form. For example, yung photodiodes, no, it convert light into an electrical current. No? That's the first type. Second one naman is yung photoresistors. So sa photoresistor or photoresistors, no, resistance decreases with increasing light intensity. So kapag ka lumiliwanag, yung resistance niya ay bumababa. Okay? So that's the photoresistor. The third one is the phototransistors. Ano naman itong phototransistor na to? Phototransistor, it acts as a transistor with light controlling the current flow. So kinokontrol nito yung flow ng current using light. Okay, that's phototransistor. The fourth one is the CCD, charge coupled device, and the CMOS image sensors. No? It capture light and convert it into digital image data. No? So, wait. So kung makikita ninyo, itong nasa, itong merong akong marker dito. This is a photodiode, this one, okay? And here naman, sa kabila, itong nasa right side naman is resistor. Okay, photoresistor naman yan. The third one is the phototransistor. Ito, no? Transistor. And ito naman isa is nakikita natin sa mga digital cameras. No? Itong CMOS or NCCD. So these are the types of light sensors. Okay? Let us now continue on the pressure sensor itself. Ano naman itong pressure sensor na to? Usually, pressure sensors, it activates when pressure is being uh, in, uh, is implemented or executed. No? If there's a pressure, then it would activate immediately itong sensor na to. No? So we have here three types of pressure sensors dito sa ating slide. The piezoresistive sensor, the strain gauge sensor, and the capacitive sensors. No? So when the pressure is applied, these sensors immediately activated. Okay, so sa piezoresistive sensors, ito naman, resistance changes due to applied pressure. Okay, so there's an applied pressure, the resistance changes. Okay, the second one is the strain gauge sensor. Ano naman itong strain gauge sensor na tinatawag? This sensor, no, measures strain caused by a pressure, which is converted into electrical resistance change. For example, nagkaroon ng deformation, itong strain gauge, it will now convert into electrical energy. Okay? So the third one is capacitive sensors, changes in capacitance occur due to pressure variations. So as you can observe, no, different pressure sensors are being activated depending on the pressure applied. Okay, the first one sa piezoresistive, nagbabago naman yung resistance due to applied pressure. So strain gauge depends on deformation. And the third one is changes in capacitance naman. Okay? So here's the example of a piezoresistive sensor. Ito, kung nakita niyo itong pula na to. And the second one is strain gauge. Nadideform tong linear strain gauge na to, no? And itong capacitive sensor naman is nadidiinan din. Again, pressure is pag-diin or pag-apply ng bigat or any form of pressure. Okay? So I have here, again, an 8-minute video. Let us watch, for your own consumption.
Welcome back, and thank you for checking out this latest video brought to you by RealPars. If you're watching this video, then you're probably wondering what exactly is a pressure sensor. Today, we will hopefully cover all of the questions you may have about pressure sensors. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new RealPars videos. This way, you never miss another one. To understand pressure sensors, first, you need to understand pressure. Pressure is an expression of force exerted on a surface per unit area. We commonly measure the pressure of liquids, air, and other gases, amongst other things. The standard unit for pressure is the Pascal. This is equivalent to 1 Newton per meter squared. A pressure sensor simply monitors this pressure and can display it in one of the several units known around the world. This is commonly the Pascal, bar, and PSI, or pounds per square inch in the United States. The pressure of the air in your tire is a great example of pressure and how it's measured. As we air the tire up, the force it exerts on the tire increases, causing the tire to inflate. This is monitored with a pressure sensor inside the tire on newer vehicles. So how does a pressure sensor work? In a nutshell, it converts the pressure to a small electrical signal that is transmitted and displayed. These are also commonly called pressure transmitters because of this. Two common signals that are used is a 4 to 20 milliamp signal and a 0 to 5 volt signal. Most pressure sensors work off of the piezoelectric effect. This is when a material creates an electric charge in response to stress. The stress is usually pressure, but can be twisting, bending, or vibrations. The pressure sensor detects the pressure and can determine the amount of pressure by measuring the electric charge. Pressure sensors need to be calibrated so it knows what voltage or milliamp signal corresponds to what pressure. This is a basic zero and span calibration, or minimum and maximum, which is a common job for maintenance personnel. In the Real Pars video, What is Sensor Calibration and Why is it Important?, we describe the sensor calibration in detail. What are some of the common types of pressure that you can measure with a pressure sensor? There are three common types that we use in the industry. First being gauge pressure. This is measured in reference to atmospheric pressure, which is typically 14.7 psi. You will show a positive pressure when it is above atmospheric pressure, and a negative when it is below atmospheric pressure. The next type is absolute pressure. Simply put, this is the pressure as measured against absolute vacuum. A full vacuum will have an absolute pressure of 0 psi-A and increase from there. If you need to read a pressure that is lower than atmospheric pressure, this is the type of sensor you would use. The last type that is commonly monitored in the industry is differential pressure. This is exactly what it sounds like, the difference between two pressures, a pressure being measured and a reference pressure. In industry, pressure sensors are used for a wide variety of processes. Some common uses are to measure the pressure of steam. Steam is commonly used to heat many processes in manufacturing facilities. This pressure sensor on the steam system can serve multiple purposes though. First and most obvious is to observe and monitor the pressure. Another purpose is to control when and where steam can flow and regulate its pressure. Steam can build up a pressure in a vessel and become dangerous. We can use the pressure sensor as an input device to open and close a control valve to keep the pressure and steam flow regulated. This only requires simple programming in the PLC to achieve this. Pressure sensors are also installed next to filters in many industrial processes. If the filter begins to clog, the flow will decrease. As the flow of the liquid decreases, pressure can increase or decrease depending on which side of the filter is monitored. If you monitor the pressure, it will give you a simple indication that the filter is clogged and needs to be cleaned or replaced. A common use that isn't as obvious is the use of a pressure sensor as a level sensor. In an open tank, you can use the hydrostatic pressure that is measured at the sensor. With a little math, using the size of the tank and specific gravity of the liquid, we can determine how much of that liquid is in the tank. If the tank is closed, it isn't as simple of an installation. It is still a viable option though. This will require at least two sensors to measure differential pressure. The high pressure sensor would be located at the bottom of the tank, measuring the liquid pressure, and the low pressure sensor near the top, measuring the air pressure inside. A calculation can then be performed to figure out how much liquid is in the tank. Let's take a look back at what we have learned. Pressure is an expression of force exerted on a surface per unit area. The standard units are the Pascal, bar, and PSI, or pounds per square inch. Pressure sensors convert the pressure into an electrical signal that can be transmitted and displayed. This is why many sensors are referred to as transmitters. These sensors commonly measure gauge pressure, absolute pressure, and differential pressure. Gauge pressure is measured against the atmospheric pressure. Absolute is measured against a vacuum, and the differential pressure is the difference between two pressures. Pressure sensors are commonly used to monitor pressures in different processes. A common thing to monitor is steam pressure. That pressure sensor can be used to control a valve to keep steam pressure at a constant level. Another common but lesser known use is to monitor the level of a liquid in a tank. Filter clogs are a common use of differential pressure monitoring. By knowing the pressure before and after the filter, you can determine if it is clogged. Thanks for watching another RealPARS video. I hope you learned about pressure sensors. Check back soon to find out how to choose a pressure transmitter. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.
So if you walked into a store in the 1990s and asked for a
so you were able to have the grasp or the idea about how pressure sensor works given in the video. No? May binigyan na sample dun yung water tank, and it was heated, and the pressure being produced is then measured by different pressure gauges or pressure sensors. Okay. So the next video we have here the motion sensor. From the word itself, the sensor is being activated by the motion it detected or it detects. So I have here samples of motion sensors. We have the accelerometer, the gyroscope, and the magnetometers. Okay. Ano ba itong accelerometer na to? So basically, accelerometers measure acceleration or changes in velocity in one or more axes. Second one is the gyroscope, measure angular velocity or the rotation rate. And the third one is magnetometers. It measures the magnetic fields often used for orientation and compass applications. So as you can see, we have here different modules for each sensor. This one is the accelerometer. And naman yan, nakikita nyo naman, accelerometer. Gyroscope, ito naman siya. No? This is the gyroscope. And this is the magnetometer. These sensors is being used depending on what project you are currently working with. Okay. So to further understand again the following videos has been referenced or researched for your own consumption. Okay.
Welcome back.
So if you walked into a store in the 1990s and asked for a motion sensor, they'd probably hand you some contraption that you hang on your garage that automatically lights up to scare away a novice burglar, or that bloody raccoon that keeps tipping over your garbage can. But while sensors that detect the motion of something else are still a mainstay of home security systems, the subject of today's video is actually the sensors that detect their own motion. So how do those work? Let's start with the kind you've probably got a couple of in your hand or pocket right now. A micro electromechanical system, or MEMS for short. A couple of examples of which are accelerometers and gyroscopes. Well, that sounds pretty fancy, Linus. What the heck are those? Well, they're both engineering and manufacturing marvels, but the basic concepts behind them are actually pretty simple. Accelerometers are for movement of your device, and the kind you'd find in your phone or a game console motion controller is pretty much a very small mass suspended by like tiny micro springs with some fixed electrodes within a housing. So let's say Shake It Off starts playing and you're frantically going like this trying to shuffle your playlist. The mass's position relative to the electrodes will change thanks to inertia, changing the capacitance between those electrodes, which your phone interprets as a shake, and suddenly you're listening to some even more deeply embarrassing song you've had on your phone so long you forgot it was there. Gyroscopes serve a similar purpose, but because they are not suspended by springs and therefore affected by gravity, they are more useful for measuring rotation. Although a good accelerometer can do a reasonable job of this unless it's in free fall as well. So these bad boys have shown up alongside accelerometers to improve input speed and accuracy. Wii Motion Plus, anyone? Oops, red shell! But consider the following. These types of devices are limited in that they can only detect a change in position relative to a starting point. What if you wanted to know exactly where your smartphone was last night? Then you'll need something that can detect absolute position, like a light detection motion controller, the place that you're most likely to find one in your house being on your video game console. The original Wii used infrared or IR light emitters, 2 of them on a little bar under your TV, and cameras in each of the controllers to pinpoint the exact location of the controller in the room to further enhance the motion control experience. The disadvantage of a light-based system is that breaking the line of sight makes them stop working entirely, and without high frame rate cameras, performance can be a little laggy and uninspiring. But fortunately, we've made a lot of progress since 2006, and newer systems like the one found on the HTC Vive head-mounted VR device use a combination of MEMS chips, laser position sensors, and passive base stations called lighthouses that work with the camera on the headset itself to perfectly determine the user's orientation and position within the room. Pretty freaking smurf. But the applications of these technologies go way beyond gaming, of course, with medical rehabilitation, fitness and sport performance tracking, and even augmented reality devices like Microsoft's HoloLens that overlays virtual objects on the real world you live in, unlocking all kinds of amazing possibilities in the future. Speaking of amazing futures, what if you didn't even have to read books for yourself? I guess that's today with Audible.com, the leading provider of audiobooks with more than 180,000 downloadable titles across all types of literature, including fiction, nonfiction, and periodicals. Audiobooks are great to listen to when you're driving, stuck in traffic, on the subway, or the bus, doing chores around the house. Audible is try out their monthlies like dip them to the mainstream. Sign up for the club. All right, guys, I think that's pretty much it. Like the video if you liked it. So if you walked into a store...
The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Hi, and welcome back to the Learning Circuit. In this video, I'm going to talk about one of the most popular motion sensors that can be found in security systems, lights, light switches, and more, the PIR sensor. If you've ever walked past a house at night or into a dark room and had the lights turn on automatically, they likely used a motion detector called a PIR sensor. PIR stands for passive infrared. Passive devices or components are those that do not generate energy, but can store it or dissipate it. Infrared is a form of electromagnetic radiation with wavelengths longer than visible light. Everything emits some low-level radiation. The hotter something is, the more radiation is emitted. PIR sensors contain pyroelectric elements that can measure infrared radiating from objects in its field of view. Let's talk about what that means. PIR sensors contain elements made up of a pyroelectric material. Pyroelectric materials are similar to the piezoelectric materials we've learned about with accelerometers. But where piezoelectric materials generate a voltage in response to movement, pyroelectric materials do so in response to temperature changes. A pyroelectric material sitting at an ambient temperature will generate no voltage. However, when that material is cooled or heated, it temporarily generates a voltage. This happens when the PIR senses a temperature change within its field of view. PIR sensors typically contain 2 or 4 pyroelectric elements. Just like with your eyes, each detects a slightly different area. So when an object that's warmer or cooler moves into view, it should be detected by just one element first, creating a difference between the 2 elements. That difference in temperature translates to sensing movement. However, with 2 elements, a sensor can only detect changes along one plane, like coming in left or right. With 4 elements, movement can also be detected from top and bottom. Though, even 4 elements may not be enough to detect movement in every direction, so mounting of the sensor should be considered carefully. Movement can only be detected once objects enter the field of view or detection area of the sensor. Looking at this array of sensors, you can see that viewing angles range from 62 degrees to 74 to 120 to 139 degrees and more. You may notice on some of these a distance is also noted: 12 meters, 2 meters, 5 meters. This is the maximum distance away from the sensor that it can detect change. Indoor PIR sensors may detect up to 20 meters, while outdoor models may be able to detect up to 150 meters. The detectable distance of a PIR sensor relies on how much of the environment the elements can see. The elements can be super tiny, but their field of view can be increased by adding a lens. You can see on this SMD PIR sensor that the model without a lens only sees 2 meters, while the model with a lens can see 5 meters. These lenses appear flat. To increase the detectable range, a certain type of lens can be used: a Fresnel lens. This PIR sensor's domed lens is made up of Fresnel lenses. My degree is actually in technical theater, so I first heard about Fresnel lenses when I was working with theatrical lighting. I was fascinated when I found out how they work. Fresnel lenses were designed to save on weight, space, and material while achieving the same qualities of a larger and denser lens. A normal lens is a solid piece of glass forming a continuous convex arc. That glass can be heavy and uses a lot of material. With a Fresnel lens, the curvature is broken down into slices, and those pieces are flattened into a much thinner lens, but still maintains the angles of the original. By adding a Fresnel lens, the detection range of a PIR can be increased significantly without drastically affecting the size of the device. Fresnel lenses were traditionally made of glass that can withstand the heat of the lamps. Since PIR sensors don't get hot, their lenses can be made of plastic. A traditional Fresnel lens looks like this, with circles rippling out from the center. This is what a PIR sensor Fresnel lens looks like. This PIR sensor has a lens broken up into 128 detectable zones, split between its 4 elements, increasing accuracy and the distance of the detectable area. So when an object, say a shape, passes in front of the background, the temperature at that point in the sensor's field of view will rise from the ambient temperature to body temperature and then back again. The sensor converts the change in infrared radiation into a change in the output voltage, and this triggers the detection. Some PIR sensors come as just the sensor unit, often with 3 pins being ground, signal, and VCC. Others come soldered to built-in processors that can help convert the analog data into a digital signal. This type of unit is extremely popular with hobbyists. It's cheap and easy to interface with. It has the same 3 pins, but also 2 pots that allow the user to vary the sensitivity and delay time for the sensor to respond to changes in its field of view. Careful when buying this type. They may all look the same, but upon closer inspection, the lenses on some are not true Fresnels, just plastic covers. Real Fresnel lenses will have multiple thumbprint-looking patterns as seen from the inside of the lens. But either way, the specs on the datasheet should be correct for that model, so just be sure to check. When looking for PIR sensors out in the wild, you might find them in security systems, contactless light switches, and motion-reactive holiday decorations. PIR sensors are only one of various types of motion sensors, but they're probably the most popular among hobbyists for their price range and ease of use. Have you used a PIR sensor in a project? I'd love to hear about it. Post about your project builds and any other questions you have on the Element 14 community on element14.com/the learning circuit. Happy learning!
Hello everyone, welcome to Instrumentation Academy. In this video, we will discuss what is a proximity sensor and how it works. Proximity sensors are
That's the motion sensors, no?